Hi everyone, in this video we are going to discuss a very specific problem. The problem is determined as exactly one counting of YouTube video views. So let's say you are building an application similar to YouTube and you want to calculate the view count on a video, but you don't want that the view counts are counted twice. So this is the functional requirement we have. We actually want to count the views on a YouTube video, but the problem is we don't want to count the YouTube video views twice due to failure in our systems. How do we solve this problem? Before actually solving this problem, let me explain you the existing setup we have. So the system would be very complicated, but I've just drawn at a very high level some of the components the system might have. Imagine this is the YouTube application, and as and when users view a video, we actually capture those events and pass those events to Apache Kafka. See, I'm just explaining this design and then I'll explain a problem in it and then I'll explain the solution in it. So we are not debating on the existing design. We are assuming that if that's the design and such a problem comes, how do we solve it? So where were we? When a user views a video on the YouTube application, we capture that event and pass on to uh, Apache Kafka or AWS Kinesis or any message broker you would like. And these events are like this video was viewed by this user, this video was viewed by this user, this video was viewed by this user, and so on. These events might have the timestamp details with them as well, and Kafka on its own maintains the message offsets. Like this was the 0th message, first message, second message, third message, and so on. Now, we built a Spark streaming solution that is consuming messages from the message broker. Now, this Spark streaming solution or Apache Flink has three stages defined in it. At the very first stage, it takes few events in a given timestamp. Let's say it reads the first two videos. Then what it does is for both of these videos, it actually fetches the existing count from a database. Now it has the existing count from the database. It has the count available from the events. It adds them in the third stage, update them to the DB, and once all these things have been successfully, all these events have been successfully processed and updated to the DB, we now will commit the offset consumption to the Kafka cluster. That yes, we have successfully processed these two events. From the next time, whenever we make a request for the consumption of events, we should start beyond the first event. We should start from the second event. So these are the four steps that at a very high level happen in the streaming application. Read the events for a given time. For the distinct videos in those events, get their current count, add the new counts to the existing counts, and then update them to the database. Finally, commit the offset. Now let's say these are the four stages 1, 2, 3, and the fourth one is committing the offset. Now we'll see what happens if any of this stage fails, and are there any scenarios where we actually count the videos less number of times or more number of times. Let's say if the stage 1 fails, that is we fail to read the events from the Apache Kafka cluster, no issue. We can apply retries over here, that if we fail to read the event at one time, we'll retry it and again read the event. So that's a very standard problem that can be easily solved by retries. If stage 1 fails, just apply a retry and start consuming the events. Let's say stage 1 succeeds, we have consumed the events for the offset ID 0 and 1. Now we move to stage 2. Now we were reading the existing counts from the database for those videos. Let's say that fails. uh, if that fails, like, this is just a read event or a read stage, right? There are no side effects for this stage. So since there are no side effects for this stage, just like stage 1 was also a read stage, we are just reading the events from the Kafka cluster. Stage 2 is also a read stage. We are reading the existing counts from the Cassandra database. We can apply retries on both of these stages to make sure that if they fail the very first time, by retries, we make sure that we are at least processing them once. Let's say the first and the second stages are solved. We come to the third stage. If it happens that at this stage, I actually was processing two videos. If it happens at this stage, I was able to successfully update the count for video 1, but I couldn't update the count for video 2. So this stage fails. I can't retry this stage because if I'll retry this entire stage, video 1's count will again get updated. Right? I can't retry this entire stage individually here. So that's a problem. If this stage fails, how can I make sure that I missed adding the count for video 1? How can I make video 2 and I successfully added the count for video 1? How can I make sure that I again update the count for video 2? Now that's a problem. Okay. Let's say there is another problem. Let's say we actually updated the counts for both of the videos in stage 3, but while sending a commit offset back to Kafka cluster, this step failed. Now what happens when this step fails? When this step fails, the next time we'll again consume these both two videos and their counts will be updated twice. Now, if this step also fails, like retrying to definitely would make us count them twice, but even if we don't retry here, we'll again consume these two videos and count them twice. Similarly, even if we don't retry at stage 3, we just fail the stage 3 and again start consuming, we'll again consume video 0 and video 1. So in this case, we had already updated the count for video 1 in the previous failed part, and now if we'll consume video 1 again, we'll count its updated counts twice. Now that's not a correct solution, alright? We are counting the counts multiple times, and that could be very much of an issue. This happens very frequently. Now in the case of videos, this might not seem very much of a problem, but let's say if we are counting the ad click impressions, right, then that becomes a very critical problem, because if we are counting the ad click impressions more than once, we are overcharging the customers, and that's a very bad customer experience. So we can't count, be it the video view impressions, be it the ad click impressions that's coming from the Apache Kafka cluster. We can't count them more than once if any of these stages fail. So then what is the requirement? We should count the each view or the each ad click impression exactly once, end to end. That is the problem we have over here. Now let us see the possible solutions. So whenever there is a problem that says that we actually want to do something exactly once, then something that is required to be solved by exact once times, it can be solved by having a sandwich approach of both at most once and at least once. If we somehow apply this sandwich approach on our system design, then we can make sure that something is happening exactly once. Now, if you see, the retries that we were applying at stage 1 and stage 2 in the previous approach was making sure that the messages are consumed at least once, right? But how can we make sure that the messages are not consumed more than once? Because The major problem was we were not undercounting the views, we were overcounting the views. We don't have to count them more than once. How can we make sure that we apply at most one strategy? Right? We don't overcount the views. We have to deduplicate the countings somehow. Like if a count has been made previously, we have to dedupe it and do not count it again, even though a retry happens. Now, if we are able to somehow do it, that makes sure that we have applied at most one strategy on a system design, and that will solve the problem for us. So I'll go ahead and present a solution how to actually implement at most once in such a use case or such a flow. So this is a similar diagram, only in the Cassandra cluster we have added one column, that is version. So rest everything is same, nothing extra is happening. So let me explain the workflow once again. From the YouTube, some click impressions are coming. In our case, it would be video views. Video I is viewed by user A, video 2 is viewed by user B, and so on. A lot of such events are coming through a Apache Kafka or AWS Kinesis cluster. Similarly, our streaming solution, the Apache Flink, it has various stages. The stage 1 reads the incoming events. If this fails, retries are applied, and that makes sure that like these events are processed at least once. Stage 2, if this fails, definitely we retry it again, making sure that we at least once read the existing count of the videos. Now let's discuss the scenario which happened at stage 3. We were supposed to update the count for 2 videos. We updated the count successfully for video 1, but we did not update the count successfully for video 2. But this time what we are doing is, while we updated successfully the count for video 1, we also store what was the last successfully updated offset we consumed. So we stored that the offset 0 corresponding to video 1 has been consumed and their counts have been successfully updated. So if we retry all the videos again, and we go ahead and add the video count for offset 0 again, so we should be rejecting them because we already consumed it. But let's say if there has no such one second, okay, so let's say if we'll retry the video 2, so no such video has already been consumed, so its count will get updated here, whereas the ones that have already been consumed the video 1, their count will not get updated. Similarly, let's say both the videos we were able to successfully write to the database, but the commit offset consumption for the Apache Kafka cluster fails. This fails, next time again we'll consume both video 1, video 2 from offset 0, 1. Will read their existing counts from the database. While read their existing counts from the database, we'll realize that their versions have already been consumed. So we won't even go to the next step, stage 3. So that's where applying the deduping using the version concept, and this version concept we are picking from the offset of the Apache Kafka, so that even if we again get the 0th offset video count impression, we see that those have already been consumed, we won't process it again. So that's basis of using this latest version or the last version we consumed for updating the video count actually helps us deduplicate the previously consumed video count impressions which we are receiving from the Apache Kafka. So retries make sure that we are consuming that event at least once. Deduping makes sure that we are consuming that event at most once. And sandwiching both at least once and at most once technologies, we are making sure that these events are processed exactly once. So no event is actually counted twice. It's counted exactly once times. So that's solve the problems, and I think this is exactly how Apache Flink solves this problem of processing the events exactly once. Now this is a very important concept. If you see, exactly once requirements are required at a lot of places. I give an example of ad clicking impressions. So like the people who publish their ads, they have to pay Google ads as many times there are clicks on their ads. Let's say the content creators, they need to be paid money. How many clicks are there on those ads? So if those clicks are counted less number of times or more number of times, the amount of money paid by the advertisers or paid to the content creators would be more or less, and that won't be right. Similarly, these concepts can be applied in a payment system where you don't want to make payments more than once or less than once. So always using the concept of retries and deduplication will help you to make sure that you only make something or perform something exactly once. Thank you guys. Thank you very much.